Okay, let's talk about where the logarithm comes from. What does it mean? And the idea is that the logarithm came originally from the exponential function as the inverse of the exponential function. And here's what that means. If we look at an exponential function, let's look at y equal 2 to the x. We know that that thing looks like this. We can ask, is it 1 to 1? 1 to 1, you might remember, means that for every y, there is only one associated x. That is to say, it passes the horizontal line test. And this graph does, so the answer is yes, it's 1 to 1. Now, what does it mean if it's 1 to 1? It means it has an inverse function. So, what's the inverse function? If you remember the y equal 2 to the x, if we just plot some points, the inverse function will be the one where we switch all the x's and the y's. So, for example, if x is 1, then y is 2. So these are just some points on the exponential function. And then we're going to switch the x's and y's and see what the exponential function looks like, the logarithmic function looks like. If x is 0, then y is 1. If x is 2, then y is 4. If x is negative 1, then y is a half. And if we're going to look at the log function, if it really is the inverse function, this is going to be the log in base 2 of x, then the x's and y's should be reversed. So, for example, we should have input x of 1 and output input x of 2 and output y of 1 by just switching these x and y values. And we can do a similar job for the other ones. 1, 0, 2, 4 becomes 4, 2. And minus 1, 1 half becomes 1 half, comma, minus 1. And this thing, we can draw a graph of it and see what it looks like. So let's take a look. What we have here is, in blue, we have y equal 2 to the x. That's the one that we're used to. You notice that on the right, it's going up, and on the left, it's curving close to that x-axis. All right. And then if we take each one of these points, for example, the point 0, 1, and if we reverse the x and the y coordinate, we make it 1, 0, that'll give us the point where x is 1 and y is 0. It gives us the point right down here. So that point, this point comes over here. The point up here, 2, 4, is going to, where that will end up is at the point 4, 2. So when x is 4 and y is 1, 2. This point ends up over here. And a point down to the left of the y-axis down here, this point was the point minus 1, 1 half. And that's going to switch itself over to be the point 1 half, minus 1 down here. And for all of these points, as they get closer and closer to that x-axis, the corresponding points on the logarithm function are going to get closer and closer to the y-axis here. So this is the logarithm in base 2 of x. You can see that's the formula given on the left-hand side. Some things to note about the logarithm in base 2 of x. First of all, the domain is not all the real numbers. You can't plug anything in here into the logarithm and get an answer. So now the domain is only positive things. However, the range, you're able to get positive numbers out of it. You're also able to get negative numbers out of it. The range is all real numbers. Let's make a note of that. So this thing has domain. It has domain 0, infinity, and range all real numbers, or minus infinity, infinity. I would probably write that R for all real numbers. It has a vertical asymptote. At x equals 0. And no horizontal asymptotes. Okay. So that's the basics. That's the log in base 2. I suppose if we want to look at the other bases, well, they're going to come out similar. They're just going to be curved a little differently. So let's take a look at what just a couple of them look like. Let's look, for example, at y is equal to the log in base 10 of x. And you'll notice that that one is similar to the log in base 2 of x, but it lies below it, above it over here. Yeah. What if we do a base that is between 0 and 1? So, for example, if y is equal to the log in base, let's say 0.5, log in base 1/2 of x. And you'll notice that this now, it looks similar to these ones, but now it sort of goes the other direction. It's like the mirror image, but the mirror image is up and down instead of side to side as it was for exponential functions. So this log with a fraction base of a base of 1/2, it approaches the x-axis, it approaches the positive y-axis, that's the asymptote, and it goes off to negative infinity to the right.